Hello, good day, and welcome to my Campus Guide channel. Today we are considering electrical circuit analysis in applied electricity. And before I proceed, if you know you have not subscribed to our channel, make sure you subscribe so you get daily updates on our videos and our tutorials on my Campus Guide channel. So let's start. So today we are looking at this circuit that you can see on your screen. So looking at this circuit, we are to do something. So the question is, find the value of the current in all resistors of the circuit below using the total resistance and the voltage drop principles. So right now, looking at the diagram there, we can see our resistors and our voltage source of 25 volts connected with resistors, some in parallel and others in series. And looking at the circuit where we can see a connection here, which is a short, which is termed in applied electricity as a short circuit. And a short circuit is termed as connection with theoretically zero resistance. So it pulls all currents towards itself, and all resistors connected parallel to it will not receive current. So in our case, the 5 ohm resistor and the 7 ohm resistor here will not receive current. So this short circuit will take off these two resistors connected in parallel with it. So our circuit now reduced. So let's start with the solution. So the first part of the solution is knowing that this short circuit is taking care of these two resistors which are connected in parallel with it. So current will not flow through them. So let's look at it. So as I said earlier, resolving because of the short circuit, our circuit diagram will reduce. So let's look at our final circuit diagram. So this is our final circuit diagram that we are going to work. This 3.5 ohm and the 3 ohm are in series. And when resistors are in series, we add them and we get their final resultant resistance, which will also be in parallel with this 4 ohm. And we also resolve that. Say resistors in parallel, we take their product and divide by their sum. We divide by their sum. So let's continue with our solution. So this 3.5 and the 3 ohm are in series, so we add and we had a resultant to be 6.5 ohm, which will be parallel to our 4 ohm resistor, So this our resultant resistance of these two resistors, it will be in parallel with 4. So with a 4 ohm, so our resultant will be the product divided by their sum. So the 6.5 times 4 divided by 6.5 plus 4, which is giving us 2.48 ohm. So that one will be our resultant. So getting this, our circuit diagram will also reduce again because we need to find our total resistance so that we can find our total current. Then we use it to solve the question which says we should find the current through all resistors in this circuit diagram. So right now, our circuit has now been reduced to this form by using our resultant resistance here, which is 2.48 ohm. And we have 1 ohm connected to our voltage source, and we also have our 2 ohm. So right now, there is our main or our reduced circuit diagram. We still want to reduce it again so that we can get our final or resultant resistance. So to find it, we can see that this 2.48 ohm is also in parallel with this 2 ohm. So when we resolve it, we get their resultant, which will be in series with 1 ohm. Then we get our final RT. Then we can find our total current in the circuit. So let's do that quickly. So we can see our 2.48 ohm, which is parallel to our 2 ohm. So we find their resultant by dividing, taking their product and dividing by their summation. So we are getting 1.107 ohm as the resultant for these 2.48 and 2 ohm resistors. So now our circuit will also reduce again to this form, which is a simple circuit. So initially we were having a complex circuit and we have been able to reduce it to a simple circuit. Then we can see that this 1 ohm is now in series with 1.107 ohm, and when they are in series, as I said earlier, we add their values. So let's do that. So we can add them. So 1 plus 1.107 will give us 2.107 ohm, which is equal to our total or our resultant resistance in the whole circuit. So that is that. So right now we can find our total current by using Ohm's law, which states that the voltage in a circuit is equal to the product of the current, total current in the circuit, and the total resistance in the circuit. So using that formula by Ohms, we can do some change of subject there to make the current our value that we are looking for after that. So we do simple change of subject. So making current the subject, so we get current which is equal to the voltage from the source divided by the total resistance. So we know the voltage from the source to be 25 volts, and we divide by 2.107 ohms. That is our total resistance. So we get 11.87 ampere as our total current in the circuit. So to achieve our total current, we can also find current through each resistor. So this 11.87 ampere is the same current that will flow through our 1 ohm resistor. So our circuit, we have to resolve back to get our total or current moving through each resistor. So we are, as I said, the resultant current will be the same current through the 1 ohm. So we are done with the current passing through the 1 ohm. So our 1 ohm current will be the total current from the source. And when this total current reaches this node at the point, it will split into 2. So I label them I1 and I2. So this I2 will be the total current which will be flowing through all the circuits which are connected on my right hand side, and this I1 will be the current that will flow through our 2 ohm resistor. So we are finding the current through our I1. So right now we need to find the current through our 2 ohm resistor. Then we can deduce an equation for it by taking this loop at a time. So we are taking this loop, look at my cursor, this loop alone. So we are using the voltage drop, which is the voltage from the source equal to the summation of all the voltages across the loop. So our 25 volts will be equal to the voltage across the 1 ohm and the voltage across the 2 ohm. So we know the current through the 1 ohm, so we multiply by the resistance, which is 1, then we can get our total voltage there. So when we get the total voltage, we can also get the current through the 2 ohm. So we can see the current through the 2 ohm, which is I1, will be 6.564 ampere. So 6.564 ampere is the current to the 2 ohm resistor. So getting this, we can also find the current through the 2.48 ohm by subtracting the current through the 2 ohm from our total or our resultant current. So we do that quickly, and we are having 5.306 ampere as a current moving to the 2.480, and this will be the current that will flow through the all resistors at my right hand side. So at this point, we can use various means to get the current that will be flowing through the resistors that are here. So we know our I2, which is the current that will be flowing, which is 5.306 ampere. So this current is coming to this node. So using the current law, which says the current coming to the node is equal to the current leaving the node. So when we add I5 and I4, we are getting the current which is coming, which is I2. So we can say that I4 will be the same current that will flow through the 3.5 ohm and the 3 ohm, and I5 will be the current that will be flowing through the 4 ohm. So let's do that. So using the current division rule, which is we are finding the current in the 4 ohm. So we take the summation of these two resistors, which is 6.5, and we divide by the summation of the 6.5 plus the 4 ohm, which will give us 3.285 ampere, which will be the current to the 4 ohm. So when we subtract this current from the total current which is coming, we get the current that will flow through the 3.5 and the 3 ohm. Thank you.